Okay, in this lecture, we're talking about statistics again. This time, we're talking about something called a categorical random variable, and these are also known as factor variables. The idea with a categorical random variable is that this is a type of random variable that takes on a limited number, a finite number of discrete, and that is to say isolated values. And I think the best way to explain these is to give some definitions. Give some examples. For instance, a pet's sex will be male or female. So again, these are categories of pets that you might have: a male pet, a female pet. A voter's political affiliation, be that Democratic, Republican. I guess you could put down Solidarity Party. You could put down Libertarian. A person's marital status. It could be they were never married, that they're currently married, they're divorced, they're widowed. The month of a child's birth, the first month, the second month, the third month, on through the 12th month. And the answer to a question that's true or false, yes or no, these are all different categories that we can name. Now, a parameter that we can associate with this is called the population proportion. And so the idea, the population proportion is a parameter related to a categorical random variable. And quite frankly, it's exactly as described, by which I mean it's the proportion of the population that a particular category makes up. So the idea here, we have the number of items in a population, which we're going to always try to use capital N for that. And then we think about the particular category that we have in mind. Okay, we have all of our values to the categorical random variable, but we have the particular category that we have in mind. Let's say we have C that are in those. So the proportion that the category that we're thinking of, or the number of items in that category, divided by the total number of items. Okay, so it's just the fraction of the population that a particular category occupies. Okay, now associated with that parameter is a statistic called the sample proportion. And the sample proportion is it estimates the population proportion. So here we take a sample of size n, okay, some sample, and then we count the number of category items in the sample. Okay. Then we take that and we divide the number of items in the category by the total number in the sample. So to make this clear, suppose that we have 500,000 beads altogether, a big vat of 500,000 beads. Imagine them to be nicely mixed up if you want to. And say that 20,000 of these colored beads are red. Okay, then the proportion of the beads that are red are 20,000 divided by the total number of 500,000. This gives us 0.04 proportion, or if you insist, 4%. It's even ugly to write out. Okay, now Suppose, though, we take a sample of 100 beads from that population. We get 5 red beads in that sample. This will give us that x over n, our sample proportion, is equal to 5 divided by 100, which is 0.05. So this 5.05 is an estimator of that proportion. And obviously they're not equal, but they're in the same neighborhood. We'll talk more about error later in the course.